Solving nonlinear systems of equations. Yes, that's exactly what we're going to do for the next 10 minutes or so, is solve a few nonlinear systems of equations. Now, I know when you look at this, you say, well, I see a line there, and I see a line. Well, if both of them aren't lines, then it's a nonlinear pair. So, let's, but that's one good point, is that you should recognize this is a parabola. You should recognize this is a line, circle, come on, circle, parabola. Not a function, sideways parabola, but still a parabola. So keep in mind that when you solve these, I'm only going to stick to three really basic methods: graphing, substitution, elimination. So when we look at this very first one right here, we can quickly see that we have a line with a y-intercept of 1 and a slope of 1. So that line's going to look just like that. Here we have a parabola. Y equals x squared is a nice happy parabola, but it's got a 1, so it goes up just like that. And I think we've already found one of our points. We found one of our ordered pairs as being 0, 1. So awesome. And I think we have another one right here. So we could guesstimate it, maybe if we plotted it on a piece of graph paper, real nice and neat. But one thing we could do here is we could use, in this case, we could use elimination. I could subtract both of these equations, boop, 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 from the top. And what would happen is y minus y is gone. X squared minus x, y minus y is 0, equals x squared minus x, 1 minus 1. So this is what we've got. Keep in mind, those are nonlinear terms, or non-like terms, non-like terms, so you can't really subtract them, but we can factor, and we get this. So now x equals 0 or x equals 1. And we already found that one with the graph right there, which is awesome. Now, if x is equal to 0, I can plug it back into either of my original equations and get 1 as the y value. And if x is 1, then the y value would be 2. So that's what that bad boy was, 1, 2. Not bad. Now, some of you are saying, that elimination kind of threw me off there, Uncle Dan. Well, that's okay. If y is equal to x squared plus 1, and y is also equal to x plus 1, we can set them equal to each other using substitution. So looking at this, we quickly see that 1 minus 1, those are gone, so x squared equals x. Now for some reason, x squared equals x, algebra students love to divide both sides by x. Dividing by an unknown value is not a good idea, because that unknown value could be 0. And you're saying, well, if I divide both sides by x, x is equal to 1, and I found an answer. Yeah, but you lost that answer. So don't do that. Don't do that. I've never known why students like to do that. I think I know why, so don't do it. So let's subtract x on each side, and now factor it, and we can easily see that we've got now the same thing that we had over here when we were using elimination. So all three of them were kind of, you're only going to pick one method for doing it, but look at how I use all three methods and blend them together. So not to confuse you, let's just use substitution on this one. I think substitution would definitely be the way to go, because what we can do is in the place of the y in the second equation, we're going to substitute 3x minus 5. Substitution method. Now I know this is a line and this is a circle, so I could get an idea of how many times could a line and a circle intersect. They could be one time, they could be no times, they might be just one time if it's tangent, it might be 2 times if it's secant. So, those are things to think about. How many answers can we expect? I remember one student once told me that, well, a line and a circle could intersect lots of times. If that circle is really big and that line goes along that edge and doesn't work that way. So let's just finish this off. X squared plus 3x minus 5 squared is 3x minus 5 times 3x minus 5, which when using FOIL is 9x squared. The outer is minus 15x, the inner is minus 15x, and the last is positive 25 equaling 5. So now let me combine all my like terms. This is 10x squared minus 30x, and let me subtract 5 on both sides. Yes, divide everything by 10. That would really help out. So x squared minus 3x plus 2. And if you can't factor this trinomial, be honest with you, you can't factor anything. And let me tell you why. Because x times x is going to give you x squared. The only two whole numbers that multiply together give you 2 are 1 and 2. So they're either going to be both positive, a positive times a positive, or they're going to be both negative. Negative times a negative is a positive. And I think they're both going to be negative so that the outer and inner can add together to equal -3. So now using our zero product property, say that 3 times fast. Zero product property. Okay. X minus 1 equals 0. X minus 2 equals 0. So x equals 1 or x equals 2. So let me set up those ordered pairs. And I want to be a little careful here because I don't want to mislead anybody. So those of you that are advanced know that when I write down here, I'm automatically assuming that I only have one solution with x equals 1. I could have 2 solutions with x equals 1. Maybe I have the plus and minus y value. Let's see. I'm not going to have it here because when I plug in 1 here, 3 times 1 is 3, minus 5 is -2. There's no way to get a positive 2. So yeah, I'm pretty straight. 3 times 2 is 6, minus 5 is 1. And let's just check them with the second equation as well. 1 squared is 1, -2 squared is 4, 1 plus 4 is 5, 2 squared is 4, 1 squared is 1, 4 plus 1 is 5. So yeah, we found it. And like I said, if we looked at this, this is simply a circle whose center is at the origin and whose radius is the square root of 5. A little bit more than 2. So it will look something like that. Here's a line whose y-intercept is -5. 1, 2, 3, 4, 5 right there. And its slope is up 3 over 1. So up 3 over 1. So this bad boy does something like that. So just based on my nasty, ugly looking graph, it should be 2, 1. Yeah, my graph is pretty stinky. 1, -2 right there. So, oh man, I really got off on those little tiki marks, didn't I? Because the radius of the circle is only supposed to be 2. So yeah, even though my graph really sucks, if you have a really nice sheet of paper and can graph it out, you might actually get nicer values. But I realize that these values look pretty close to what my sucky graph looks like. That's pretty cool. So let's look at the third and final one right there. I could use substitution for this one. I'm going to use elimination. And I'm going to be a little careful here because I see that my y's in both equations are squared. So that lets me know right there that, wow, if a -2 for y is a solution, then +2 for y is going to be a solution. Because -2 squared and +2 squared both give you 4. And notice that all my y's are squared, so I got to be a little careful there. The same's not going to be true with the x's, since this x is raised only to the first power. So I want to be cautious about the y values. So let's just see what happens. Like I said, I'll use elimination. What I'm going to do is keep this x squared plus y squared equals 4. And I'm going to multiply this equation by -1 and add them together, as opposed to subtracting. You know, that just makes me feel better. So if I multiply this by -1, I get -y squared plus x equals -4. So what happens here very quickly is my y squared minus y squared are gone. 4 minus 4 are gone. So I'm left with x squared plus x equals 0. Very similar to the first example. So now let me factor out an x. And I see very quickly that my solutions now are going to be x equals 0 and x equals -1. But once again, by writing this like this, I'm kind of mentally saying that I'm only going to get 2 solutions. And I may get more, so I need to be really careful here. Maybe it would behoove me, never get to use that word, I like that word. It would behoove me to say x equals 0 and x equals -1, and then find out what solutions we may have with this. Because watch, when I plug in x equals 0, I get y squared equals 4. Which means that for x equals 0, y could equal to -2 or +2. Let me plug it into this one. If x equals 0, y squared equals 4. So keep in mind, when I take the square root of both sides, y could equal plus or minus 2. When I plug in -1, let's see what happens. If I plug in -1, that's y squared plus 1 equals 4, or y squared equals 3. So if y squared equals 3, y could equal negative square root of 3 or positive square root of 3. Same thing for the first equation. When I plug in -1 for x, I get 4 minus -1 squared And remember, negative 1 squared is 1. So that's, again, y squared equals 3. So y would equal plus or minus the square root of 3. So by writing your, by saying, oh, I got x and I got y, now I just need to find out, or I got x and I got x, let me find out what my y is. Got to be a little careful here. So really what we've got here is x equals 0, y is equal to negative 2, or possibly positive 2. X is equal to negative 1, y could be negative square root of 3, or y could be equal to positive square root of 3. So, in this case, we had a circle, and this circle probably looked, well, it did look just like this. It has a radius of 2, but we have the sideways parabola. And based on our solutions, just looking at them, wow. I mean, 0, negative 2 is right there, 0, positive 2. And then we have what? Negative 1 square root. So this little parabola probably did something just like this and hit it twice there and twice there. So keep in mind, a circle and a parabola may not intersect at all. They may intersect once. They may intersect 3 times. They could intersect 4 times. Could they intersect 5, 6, 7, an infinite number? Something to think about. Recognizing these, knowing which methods we can use to solve them, recognizing when we have more ordered pairs, being able to factor, taking the square root, lots of concepts, which is why math is so easy. It is pretty cumulative, isn't it? We solved a bunch of nonlinear systems of equations.